beyond CPCTC. So whereas yesterday we did the CPCTC step, this one, it makes sense I'm calling it beyond CPCTC, so we're going to take an additional step. So this is going to be something you're probably going to have to refer back to in your notes when you're doing today's worksheets. So when we're done today, you should have enough time to trim it down and again attach it to the next 2 pages. So really today you need to focus on just listening, because it's not as obvious as yesterday's. Okay, so if I look at the picture here, hopefully you notice that there are 2 triangles that should be congruent based on their markings. So just listen and I'll kind of explain, I'll do the talking today. So the 2 triangles that should be congruent, you might call one of them triangle ARE, and that would be congruent to the other triangle would be FRE. And that would be congruent based on the markings, side, side, side. Now notice in this mini proof that's set up, okay, I know the next step is going to be CPCTC because that's what we talked about yesterday. But we're not stopping there. We want to prove in this one that ray RE bisects angle FRA. So what I would do, especially if you're struggling with these, is in the picture I would trace this part here. So we are bisecting angle FRA. So some of what we're doing today is us working backwards or thinking backwards. Okay.
These angles are FRE and angle ARE is what CPTC.
Okay, very good. So, like Logan is correct. When you're thinking backwards, think, and if you need to, bless you, look back at your note cards. When you are bisecting an angle, so when you're bisecting an angle, you end up with congruent angles. Now the angles that are congruent have to be at this vertex. The vertex is R, right? So I'm looking at this picture over here at R. So we're going to have our CPCTC step is going to be what he said. Angle FRE is congruent to angle ARE, and that's my CPCTC step. So again, what you're going to have to do is look back, think backwards. What do I have to know, or what can I conclude if I knew that was bisected? That's going to be that CPCTC step. Now, here's the kicker. Your last reason is not given. No. It's going to be the converse. Remember we talked about converses when we did that video, and we said the converse is when you switch the hypothesis and conclusion. Since we're starting with the angles being congruent, and we're ending with the angle gets bisected. Everybody with me here? We're going in opposite directions. Normally, this would be part of the given when the angle got bisected, and we would conclude this, right? Today, we're going in the other direction. So when we write the reason, it's going to be the converse of what we have in our notebook already. So I'm going to give myself a little more space to write so it doesn't have to be so tiny. So what you're going to write for this particular reason is something like this. Let me pick black instead of red just so it's easier to read. So you would say something like, if a ray divides an angle into 2 congruent angles, then it bisects the angle. So again, normally we would have said if a ray bisects an angle, then it divides the angle into 2 congruent angles. Since we're flipping the spots today, we're going to write the converse of that reason. So to some extent, if you've got the proofs congruent down for the most part, and the CPCTC step was pretty easy, I think, for most people yesterday, this just takes a little bit more thought. You don't know off the top of your head what the CPCTC step has to be. You have to think about what do you want to end up with to get that CPCTC step. So it requires you to think backwards a little bit. So again, make sure you have this reason down, because on today's worksheet, if your problem ends with bisecting an angle, this is the reason you're going to put down.
Ain't those in our
notebook?
Yes, but it's the converse of what you have in your notebook. So on your quiz, or not on your quiz, this is not your quiz tomorrow, but on your test, if you put the other direction when it should be this direction, I will take off partial credit because you're going in the wrong order. Remember how we talked about just because the statement is true does not mean the converse is true. They say two different things. Okay, so make sure you do have the right order here. Okay, questions on this one? It's a little different. Okay, let's continue on then. Let's look at, there's what, 4 of these total, 2 on each page? Okay, so this one. This next one, hopefully looking at the picture, you can obviously see 2 triangles that are congruent. So one of them is going to be triangle CRS. That is going to be congruent to triangle MRE. And my reason is going to be angle, side, angle. Notice the side is between the 2 angles. Okay, so again, based on the concept that I want to prove R is the midpoint of segment SE. To figure out your CPCTC step, you might need to trace segment SE. So if I highlight it in the picture, I highlighted segment SE. So let me ask you guys. If I want to know that R is the midpoint of SE, which segments off of SE would have to be congruent? Okay, so segment SR would be congruent to segment ER or RE by CPCTC. So you got to think backwards. If you want to end up with midpoint, you're going to have segments congruent, right? If you want to end up with an angle gets bisected, we're going to have angles congruent. So it's thinking back to those words, those key words again. What does that tell you? Okay, so if I'm going to give the reason here, it's going to be the converse of what we had before. So I'm going to scroll down a little bit more, especially for people in the back, so it's easier to see. So I'm going to, do something a little bit like this. So I would say, if a point, PT means point there, divides a segment into 2 congruent segments, then it is the midpoint. So this is the other direction than what's originally in your note card. Your note card would say something like, if a point is the midpoint of a segment, then it divides the segment into 2 congruent segments. This is going the other direction. So again, if a point divides a segment into 2 congruent segments, then it is the midpoint. So very similar, we're just looking at the other order of it. So again, make sure you have this written down. I think you have 6 proofs tonight, and we'll take a look at one together. But again, if you're dealing with midpoint, your reason should have midpoint in it. It's again looking at those key words. Okay, so we have 2 to do on the second page yet, right? So we did angle bisector, we did midpoint. The last 2 we're going to look at are going to be, let's see here, isosceles triangle and bisecting a segment. Those are the only 4 endings that we're going to deal with. Okay, were we in advanced geometry, we would take a look at other options. But for here, we're just going to look at these 4 endings. Okay, so if we take a look at the isosceles one, apologize, you guys can get started if you know what you're doing. My technology is just taking a little bit longer. There we go. Okay, so on this particular one, again, hopefully on the picture, you notice that we have enough to state that 2 triangles are congruent. So in this picture, it would be triangle DAK, or a different order if you prefer. But if I do DAK, the other one is going to be RAK. And my reason, based on my picture, is going to be SAS, side angle side. Okay, now, to think about the CPCTC step, we want to end with triangle DKR being isosceles. So if I highlight triangle DKR, that's the big triangle in the picture. No offense to Logan, but somebody else besides Logan, what sides would be congruent then? Okay, DK and RK. So that's going to be my CPCTC step. So I'm going to say segment DK is congruent to segment RK by CPCTC. And then my reason is going to be the converse of what I had originally on my note cards. Okay, so hopefully everybody has this written down. If I take that away so I can scroll down and write a little bit larger, I'm going to say something like this. If a triangle has two congruent sides, then it is isosceles. So normally on our note card it said if a triangle is isosceles, then it has two congruent sides. This is just the converse of it, the other direction. If a triangle has two congruent sides, then it is isosceles. So if your proof, one of them tonight ends with the triangle being isosceles, this is going to be your reason. Now, don't get me wrong, they're not going to be this short. You're going to still, like we did yesterday, have to prove the triangle's congruent first. Then you're going to have your CPCTC step, and then whatever you're trying to prove at the end. Okay, so let's take a look at the very last one we have here in the notes. So on this one, now I have a lot of triangles in the picture, but do you see only two of them have markings on it? Yeah. Okay, so the two triangles that are marked congruent in the picture are these two small ones. So we might have something like triangle ERP congruent to triangle YRP. And my method is going to be angle, angle, side. If you look at the picture, we've got the right angle. This looks like an acute angle. And then the side. Angle, angle, side. So again, what I want to end up with is a segment getting bisected. Okay, so if I trace in the picture segment EY, because it's not an angle being bisected, it's a segment. So again, if I trace EY here in yellow, what happens when you bisect a segment? What do we end up with? Two congruent segments, right? So what segments are off of this yellow one? Okay, so you got to pick off the yellow one. So ER and YR or RY, good. That's going to be your CPCTC step. So if you're bisecting a segment, you're going to want segments congruent. The very first one we did today, we bisected an angle, right? So we wanted angles to be congruent. So you got to pay attention to what's going on here. This is the segment symbol. We're bisecting a segment. So again, my reason for the last one here is going to be the converse of, again, what I had for segment bisector. So it's going to go something like this. If a segment divides a segment into congruent segments, then it bisects the segment. So if a segment divides a segment into two congruent segments, then it bisects the segment. So again, we've been taking these in a slow progression, if you think about it. We did easy proofs for proving triangles congruent first. Then we went eventually beyond the basics, right? We added more options. And then we just yesterday took the step for CPCTC. And then this is the final step we're actually going to take with proving triangles congruent. We're going to take this final step. Our proofs are not going to get any longer than this step at the end here. Okay.